This is Jana, and I'm going to be explaining the 3.13 to 3.18 physics course revision quizzes. Okay, so for the first part of this question, they're asking us to find acceleration. Okay, we don't have any force, so we can use the F equals ma, so we can't use that one. Okay, let's try to think of any other equation that we can use using the given. We have one of equation we learned a long time ago, but still this year. It's V equals AT plus V naught. Okay, so V is the final position. A is the acceleration, and that's what we're needing to find. T is the time, and V naught is the initial speed. Okay, so here it is. Okay, and the V final is at the end. Okay, they're telling us that the block stops. That means V final equals 0. Let me write final here. Okay, and then time is 5 seconds and V initial is 10. Okay, so let's rewrite our equation. V final equals AT plus V naught. V final is 0. A, we don't know it yet, so we just write A. T is 5 seconds, so let's write 5. Plus V naught, we said initial speed is the same thing. So, and plus 10 meters per second. You do it on your calculator. You can't really do anything on your calculator till now. So 0, 5a plus 10. We move 10 to the other side. It becomes minus 10 equals 5a. So a equals minus 10 over 5. So it's equal to minus 2. And that's your answer here. Okay, that's the first part. Now, the second part, they're asking for the normal reaction. They're telling you that it's moving high. Okay, so it's not going up nor going down. So the normal force cancels the weight. Okay, so if we want to find what the normal force is, we can find the weight, because that's what we can find. We can't really find normal force. We find the weight, and then the weight will be equal to the normal reaction. Okay, so we know that weight equals mg, and m is the mass. Okay, make sure that your mass is in kilograms and not grams. If it's in grams, you divide by 1,000. Okay, so 10, and then the gravity is 10 also, so it's equal to 100, and that's your weight and your normal force at the same time, because they cancel each other. Okay, then we have magnitude. Magnitude is also called force. Okay, so F, we know that we have a formula that states F equals, oh my god, okay, F equals M A. Okay, so M is mass, obviously, so 1 or 10. Okay, and acceleration, we found it at the first part, it's minus 2. So 10 multiplied by minus 2 is minus 20. But you can't have a magnitude that's negative. So you just take the negative sign out and you get 10. Okay, that's it. Next question. Okay, for this question, here we have F1, okay, and F3. They're opposites, and F3 is larger. Okay, so we just forget about F2 right now. Okay, so let's cancel the forces. You get it going down. Okay, but since you also have this side here, the F2. Okay, you have the F2. So it's going down, but it's going in this like the side of F2 also. So this is the only one that's going down and to an angle, okay? The other one's just going up. This is going straight down. We can't have that because we still have F2. This is going straight to the side. We can't have that too. And this is going up. Up is the smallest force, so we can't have it going up. Question 3. Okay, for the first part, we know that for the magnitude is 4. Okay, so we know that F equals ma for magnitude. Magnitude is F, okay? So, we have mass, but do we have acceleration? No, we don't, okay? So, we need to find acceleration. So, in the previous question number 1, we used the formula that states F final equals AT plus F naught, okay? Let's remember this, okay? So here we have time, which is 5 seconds. We have initial velocity, which is initially traveling at 225, so it's 25, and seconds once the brakes are applied. Brakes means stop, so your final is 8. Okay? So let's do 0 equals A, because we don't know A. T is 5. V plus V is 25, okay? We move 25 to the other side. Do it from up so I can have space to write. So 25 negative equals 5A. You divide by 5. A equals minus 5, okay? Here, like I said, we can use a negative acceleration actually. So let's remember that. Now we go back to the formula that states F equals ma. We have our m, which is 1200, and we have our a, which is negative 5. Okay, so let's do it on our calculators. I'm pretty sure you all have a calculator. So 1200 times negative 5, and you get negative 6,000. Okay, like I said, you can't have a magnitude or a force that's a negative, so we just change it into a positive. Okay, and that's how you find the first part. Now in the second part, they're telling you what would be the net force, okay, if the car moves uniformly. That means it's moving in a constant speed or it's at rest, okay? So both of these are 0 newtons, so 0 force, so that's the answer, okay? And that's 3.13 done, which everyone thought was hard and it wasn't, okay? Let's do 3.14 now, okay? Okay, so the first part states what's the weight. We know we have a formula that goes weight equals mg, okay? We have the mass, which is 2 kg. Like I said, if we have it in grams, you have to change it to kilograms. So 2, okay, that does not look like a 2, so let's fix it. Okay, and we have gravity, which is 10, okay, so 10. So automatically 2 times 10, 20, and that's your weight. It's not circling. Okay, now tension. A lot of people might not know what the rule for tension is, but the rule for tension, okay, it's m, like the rule for weight, times the rule for forces, so m acceleration, okay? So we have the mass is 2 times 10 times, the rule is mg plus ma. I'm so sorry if I confused you. So it's weight plus force, okay? So the weight is 2 times 10, which is 20. We already found it, but let's just simplify things. Plus ma, which is 2, and the acceleration, they told us accelerates at 1 meter per second, so it's 1. So 2 times 10 is 20. 2 times 1 is 2. So 20 plus 2 is 22. And that's that one, okay? Now question number 2. Okay, like I said, we literally used this rule in the last question. So weight is always, oh my god, weight is always mg, and if they want you to find m from mg, you can go m equals weight over grams, okay? Only if they're asking for m. Let's not confuse you guys, and let's just memorize this. And if you want to memorize the triangle just goes like weight up here and then mg here, okay? And that's your answer here, okay? The second part, they're asking you know the gravitational field, which is the weight of what is the weight. Never mind. Okay, gravity is strength is 9.80. What is the weight of the box? Like I said, weight is mg, and if you forgot, you can just, I don't know why you would forget it. The answer is here. So m, we have it here, it's 5, so equals 5.00 times 9.80. You go on your calculator. 5 times 9.8 equals 49. And that's your answer. Now let's go question number 3. Okay. Whenever you see free falling, that means it's constant or 0 newtons. Okay. So that's your answer, constant. Okay. That's 3.14 done. 3.15 now. Okay, so for this question, you just have to memorize these. There's no other way to just remember them. You just have to memorize them. Stroke photograph. So remember, photo, you're photoing the how fast it goes, whatever. Stop clock, stop, and ticker. Okay, let me give you, I guess, how I memorize this, okay? For me, photos, I always like photos, so this is one. Stop clock, electronic, let's use electronics, we love electronics, so that's one. Ticker timer, we always use timers whenever we need anything, so that's one. Spring balance, why would we need that? Speedometer, do we drive cars? No, so we don't need that too. And that's how I memorize it. Okay, the magnitude of G measured by the tube. Okay, so we need G. Okay, so for this question, they're asking for the magnitude of G, which G is the acceleration due to gravity, which is G, okay? So, we know we want to find A. There's, I think, many ways, but the way I find the easiest, we know there's a formula that goes x, which is the distance traveled, equals half, okay, half of a t squared, okay, squared. This is a 2, okay? So let's like twist it around a bit to get a to be alone on the side. So we do a. If you don't know how to like flip it around, just memorize this equation. A equals 2x over t squared, okay? So let's fill in the values now, okay? 2x, x, like I said, is distance, so 1.5, okay? So 1.5 over t squared, so t is 0.553, okay? So 0.553 squared. Do it on your calculator, you get 9.8100448832. They want to the correct number of significant figures, so you have to figure it out from here, okay? Here we have, here's 3 significant figures and here's 3 significant figures. So we want 3 significant figures. Like I said, the number we got was 9.8100, 4, whatever, okay? So to 3 significant figures, it's 9.81, and that's that answer. And that's 3.15 done. Let's go 3.16. Okay, so for this question, we need to know the rule that goes Fg equals G multiplied by M1 M times M2 over R squared, okay? R is the distance between the objects, M1 and M2 are the two objects, and G is gravity, okay? The gravitational constant, okay? Most of the time it's 6.67 times 10 to the power of negative 11, okay? So, in this question, the first part, they're telling you that R is doubled, okay? So we double R, so R times 2, so it's 2R squared. 2R, wait. 2, what am I doing? Okay, 2R squared, okay? So, when we like distribute the squared, you get 4R squared, okay? Then, so it will be 1 over 4, because M1 and M2 stay the same. So 1 over 4 is quarter, okay? So when R is doubled, F is quartered, okay? Now, both masses are doubled. So let's go back to our equation. Oh my god, I stopped knowing how to talk. Both masses are doubled. So 1, oh my goodness, 2m1 times 2m2 over r, oh my god, r squared. So 2r squared, let's put the g so you don't think I forgot it. Okay, so here it will be 4 over 1, so 4 is so f, so when the both masses are doubled, f is quadrupled. Quartered is 1 over 4, quadrupled is times 4, okay? So now they want if the masses are doubled, both of them, and the distance is also doubled, okay? So 2m times 2m, I1, y2, you know that already, and 4 radical 4 and 4r squared. Okay, let's simplify because we can simplify here. So 2, you divide 2 and 4, this becomes 2, and then you also simplify this and this. It will be literally the same exact equation, so it remains unchanged. Okay, let's go second question. Okay, this is coming, this I think came in another, no, okay, it didn't. I was just solving the AMS a minute ago, and that's why I saw this question. Okay, so we literally did this last question, but it was worded differently. Okay, 2d, which is 2 distance, which is r, because I told you that r is distance. Okay, so we know that f of g equals g times m1 times m2 over r squared. They're telling us the distance is squared, distance is multiplied by 2, so it becomes m1 times m2 over 2r2, which is, like I solved it, 4r2. So it's 1 over 4. So 1 over 4 as a decimal, do it on your calculator if you don't know, but I think most of us know that 1 over 4 is 0.25. So that's your answer. Now let's go with the third question, which is the last question. Okay, for this question, they might word it for you different. They might ask you to specify different words, so you have to memorize this exact sentence, okay? So for the grade 9s, this question in the AMS quiz, they gave them different like choices. They didn't ask them for directly proportional. They asked them this word, square and distance. They didn't ask directly and inversely. No, they asked, where is it? They asked for the masses. So they were asking what is directly proportional to the product? It's their masses. And what was inversely proportional to the blank, which is square, of the distance of the blank between them. So the square of the distance. So you have to memorize this exact sentence. There's not really any explaining to do in this one. Just please memorize every single word of this question. And that's 3.16 done. Yeah, 3.16. Okay, let's go 3.17. 3.17 is one question. Okay, this is about satellites. We know that a satellite keeps going around its orbit. So this is the satellite. It keeps going around circles because its weight is pulling it down. Nothing else. The only thing that acts on a satellite is its weight. This you have to know 100% sure, like your name, that the only thing that acts on a satellite, the only force that acts on a satellite, it's its weight. So the only force, they're asking for force, and the only force we know is weight. So that's your answer. And then they're asking what is the best direction of this force. We know that weight, that the force of weight pulls it's downwards. So which one of these is going downwards? This is going up, this is going down, this is going to the right, yeah, and this is going to the left. So this is the only one that's going downwards. That's 3.17 done. Let's go 3.18. 3.18. Okay. Which of the following factors affect the air resistance on an object? Okay, so first thing, the surface area. If you have more surface area, let's start with this because I feel like these two are easier than the first one, okay? So when you have more surface area, does it affect air resistance? Yes, it does, because more surface area leads to more air resistance because there's more like surface blocking the air. So yes, that affects air resistance. Now shape. If you have more surface area, that means you have a bigger shape, and if you have smaller surface area, that means you have a smaller shape. So shape is kind of the same thing as area, but it's kind of worded different. So shape and surface area is the same, okay? The relative speed of the object with respect to air, okay? Here, for me, the way I know this question is because it has air in it. Air resistance, air. But don't base all your answers off that, okay? Let's read it and let's analyze it, okay? So the relative speed of the object with respect to air. So that means the speed of the object, how much it's going, how fast it's going. Yes, it does affect the air because it affects how fast or slow the air hits it, okay? So let's go to the next question. The density, that doesn't really count. And the temperature, why would I care about the temperature? Okay. So here they're telling us that the skydiver is free falling. So it's 0 newtons, so 0 force. After a certain interval of time, he reaches a constant speed. Okay. What does that mean? Terminal velocity, let's analyze what terminal velocity is. Terminal velocity is when like an object, okay, reaches constant speed after time. So air resistance at the beginning is hitting more, is hitting less. So like air resistance is this small, it's hitting less than its. Okay, wait, let's draw the diagram again. Okay, so terminal velocity is when the weight of a falling body is equal in magnitude to the air resistance exerted on it. That's what it means. I literally opened the definition on my copybook just to explain it to you, okay? So that's what it means. But now let's analyze it, okay? So when the skydiver falls immediately, its weight will be way heavier, way like more effective than its air resistance, okay, because it's still like brand new, okay. And then by time the air resistance increases while the weight obviously stays the same, and then by the time the air resistance reaches the same magnitude to the weight. This is air and this is weight, air resistance, okay, and this is weight. By the time they reach the same magnitude, that means we reached terminal velocity, okay. So here they're telling us after a certain interval of time he reached a constant speed. What does that mean? That means it's terminal velocity. What is the net force acting on high? When they say constant speed means 0 newtons. That's the net force. Okay, now we want to find the magnitude of air resistance at that moment of time. And as we know, air resistance was equal to the weight at that moment of time. So we don't have the values to find air resistance, but we have the values to find weight, okay? So we know that weight equals mg. M here is 60 kg, so 60 times gravity is 10, so 60 times 10 is 600. And that's your answer here. Let's go to the second question. Okay, this is also coming in the AMS, okay? So this, I would like to memorize this because there's not really any explaining. You just need to know the steps, okay? So first thing, obviously the first thing is that he jumps off the plane. Why would we have all of this if he's not jumping? Second thing, he keeps speeding up. Like I said, he keeps speeding up with air resistance until he reaches terminal velocity. And then, because we reach terminal velocity, we reach a constant speed. So his he opens his parachute because he reached terminal velocity. There's nothing stopping him. And then he starts slowing down because he opened his parachute. And then he reaches terminal, the speed decreases until he reaches terminal velocity. Okay, because it reaches terminal velocity, at the end will be 0. So that's the order. Just memorize these. Don't memorize the order because it's not going to be the same. Okay, now let's go to 4. Okay, here is also constant velocity falling down from a parachute. That all means terminal velocity. Okay, we know terminal velocity, weight is equal to air resistance. So here they're telling us that 800 newtons is the weight. So the air resistance is also 800. But we know they want also the direction. Okay, we know the direction of weight is down. And the air resistance is opposite to it, so it's up, so it's 8 newtons upwards, okay? Now, this is kind of like the diagram I explained terminal velocity with to you, okay? So first thing, he falls off the parachute, there's no air resistance, so this is the first one. And then air resistance slowly starts to go up, so this is small, and then this is a bit bigger, and this is way bigger, and it's equal to weight. Okay, so it goes 2, 3, and 4. That's it. Now, I think that's us done. So this is 3.13 till 3.18 for physics course revision quizzes done. I hope you understood because I think it was very, very easy. And good luck in your exam.